is Lillian Podlog, and I'm a software developer with Fluree. I'm very excited to show you this demo today. In this demo, we're going to be peeking into the life of 100 airplanes over the course of the month. These airplanes have trips that they've taken around the world, as well as repairs that they've had to have along the way. Fluree is really well suited to a database like this because we track the history of every single piece of information that is in our database in a space-efficient manner. So you can instantaneously see the state of a database at any given point in time. In addition, every single update that's made to our database has to be cryptographically hashed and signed to be accepted. And so there is an extreme level of data integrity. When you're talking about something like airplane part tracking, that integrity is people's lives. So it's really, really crucial. And so with our database, you know exactly who made a particular update and when they made that update. If you're following along with this little demo, then you can click on the repository in the link below. And you don't actually have to follow along in order to get something out of this video because it's going to be pretty high level. I'm going to walk through the demo. I'm going to talk about some of the smart functions that I use to simulate the data and how you can and look at the user interface where you can slice the data in different ways and look at it in different ways. So here, let's say that you all have git cloned down the repository. And so this is what you're going to find in there. You're going to find one folder called airplane parts, which is a folder containing a little React user interface. And then you're going to find a data folder, which actually contains that month-long worth of data, of simulated data of 100 different airplanes. You're also going to find a default private key.txt and a schema.json just for your own use. But what we're going to do is I have a blank Fluree database here. So if you download Fluree, you're going to have a folder that looks like this. It's going to have a changelog, a version. Most importantly, it's going to have the jar file, fluree_server.jar. The name might be different depending on what version you're using. You're going to have the jar file. You're going to have a properties file. And then you're going to have a fluree_start.sh, which is just the script to start up FlureeDB. And what's really, really important is that you need to start with a blank Fluree database. So make sure you don't have a data folder in there. Make sure you don't have a default private key in there, because all of the data in this particular database is signed with this particular private key. So you want to make sure that you don't have any other data in there, and make sure that your properties file, Fluree_sample.properties, is the default properties file, or if you've changed anything that you know what you're doing. So you can very safely change the port that you're looking at it on, but there's some other configurations that if you want to follow along with the demo, then you probably shouldn't change those configurations. So what I'm going to do is I'm going to move this data folder into that location. So for me, that's inside of downloads, inside of Fluree 0.10.3. And I'm going to do the same thing for my default private key. I'm sure there's a way to do this all at once, but this is how I'm doing it today. So here we go. And now we can see that, now we can see that the only thing that we have inside of this folder that I downloaded is my airplane parts and my schema.json. And inside of this folder, I now have my data and my default private key.txt. So the first thing I'm going to do is I'm just going to start up FlureeDB with Fluree_start.sh. And that's going to load up this database that I have in there. And there's a lot of blocks in there. So it's making sure, one of the things that Fluree does when it starts up is it makes sure that there's a continuous sequence of blocks. So I believe there's something like, there's several thousand blocks in this database because there's a lot of information. So we're checking that all database files are synchronized and starting web server on port 8080 with an open API. So once we see this, then we start serving the web server to port 8080. But until we see this line that says all database files are synchronized, you're not actually going to be able to do anything because we're still checking to make sure that there's a continuous chain of files. And this is really important. As a side note, when you have a network of several servers working together and one of them has been down for a while. So you want to make sure that when that server rejoins the network that they have every single file, every single block file, index file, all the things that they need. But long story short, this is starting web server on port 8080 with an open API. And that means that the with an open API part means that we are automatically signing every single new transaction with the default private key that we have, which is this one. And then all the queries, anyone can issue any query. And this is for ease of access for this demo, but if you're running this in production, you probably want to do it with a closed API where you don't have a default private key. Rather, every single update that is made to that database needs to be signed with that particular user's private key. So we're going to go over to Chrome here, and I'm going to look at localhost 8080, which I already have going. And you can see that there's one database, which is our plain/demo. And if we go over to Fluree QL, I'm going to close out history. And I'm just going to look at select star from collection. If I select star from collection, I see all of the collections that I have in my database. So I have airports, I have manufacturers, I have issues, locations, trips, parts, repairs, people, sections, people, planes, and airlines. So just to do kind of from top down. So if I select star from airline, you can see that there's only one airline in this example database. It's called Fluree Airline. And that airline has a number of planes. So it's actually 100 different planes. So we can select star from plane. And you can see, so I have 101 planes rather. So you can see that each plane has an ID and an underscore ID. So this is our system created ID, which is unique and increments by one for every new subject in a particular collection. But we also have our own ID, which you might have for lots of different cases, but this ID just increments from 1 all the way up to 101. We also have a plane name, which is a UUID, because this is randomly generated data. We have a plane type, which again is just, this is a Boeing 747-8. Again, just randomly generated from a list of airplanes. And we have a manufacturer, which I believe for this example database, you all can play around with it. But I believe the only manufacturer that I actually used was Boeing as an example. But you could have more than that, obviously. I have a manufacturer date. I have a number of plane trips, which we'll look into later. And I have plane sections. So I'd actually like to look into sections first. So I'm going to select star from sections, and I'm going to limit it to, let's say, 10 sections. So you can see that, well, actually, let me do this. So we saw that plane had this predicate sections. So if we want to select 10 sections and look backwards, do a reverse lookup, we can actually, in a single query, look up the plane name or any sort of information that we want about the plane starting from this section. So that's what I'm doing here. So here's the plane name for this particular plane, and I'll actually select ID because that's also a lot easier to look at. So for plane with ID 101, this is one of the sections that it has, and it has section ID, it has section type, and it has a number of section parts. And so if we continue following the graph, we can see, and I'm just going to select from this single section here, we can see all of the section parts and kind of more information about those parts. So we do that, and we see, okay, every single part has a serial number. So here's the, what we saw before. Is their plane ID right here, section ID, type, and all of our parts. So for this particular section. So each part has a serial number, each part has a type, each part has an install date, whether or not it's in the original part, and the manufacturer. And so you can see that for all of the parts. If we also saw when we looked at all of our collections that we have a collection called repairs. And every single repair has this information. It has a repair start date. It has the plane that's being repaired, the lead person for that repair, a repair description, a repair name, which is just a UUID, and here we have a repair part. So there's a reference from the repair to the particular part that we're repairing. And for simplicity's sake, since this is all randomly generated data, each repair has a single part. But if you're doing this in production, you'd probably want to make this a multi-ref, so each repair can hit multiple parts. But here's an end location, and here's an end date, and here's the repair location. So repairs have locations, and those are the locations where the plane was at a given point in time when it was being repaired. And you can kind of explore this database in further detail, but rather than do that, I want to show you this little user interface that I've created to delve into the data a little bit more. So I'm going to go into that airplane parts folder right here. And like I said, it's just a React application that is speaking to this database over here. So let's see, this is import 8080, and we have airplane parts. So I'm gonna, if you're downloading this for the first time, you're gonna have to do npm install, but I just need to do npm start because I already have everything installed. And I'm just gonna check real quick. Well, we'll be able to see. I'm not sure if the port is in the right place. Oh, it is. So it's pointing to the right port. So it's pulling data directly from this database that we have loaded up. So in order for this app to work, you need to make sure that your database is running. And also, right now, this app is pointed to localhost 8080. If you change the port that your database is running on, you have to go into the code for the user interface and actually change the port that it's sending its requests to. And I believe that's in Fluree fetch, the Fluree fetch.json file, which is in the top level of that directory there. But you can see, so this really demonstrates how easy it is to pull data across a cross-section in FlureeDB. So we can explore different items. We can explore planes. So let's say we can select a plane, like plane number 19. And I'm going to sort this by date. And so you can see that here's our trip. First, this plane took a trip from Damiel to Karumba International. And then in Karumba International, it was fixed. It was broken, we fixed it, as our very descriptive repair description. And then that plane actually took off from Karumba International to Chubu Centrair International. And you can see that there's continuity in where the plane took off and landed, and then where the repair was taken. And like I said, this is all simulated data. And what's really cool about the way in which this data was simulated is that I actually used smart functions to simulate the data. So smart functions embedded directly in the transactions, and we'll take a look at that shortly. But yeah, you can just kind of flip through it, and you can see these trips back and forth, these repairs, the start and end dates for these trips. The start and end dates definitely don't make any sense. I think it was just a random amount of time, less than 16 hours. So some of them are very, very quick. Some of them are very, very long. But yeah, you can see the different planes, and you can see these planes across time. One thing to note is that these times are actually times that we inputted ourselves. In FlureeDB, there's the concept of history. So every single piece of information, you can see that history of that piece of information. But the history doesn't actually match the dates because this is all simulated data. So there's a little workaround that we did by actually putting in our own dates. But if you were doing this in real time, over the course of a month, then you would be able to use the history and the time travel queries explicitly to see this data. And we can also look at airports. So let me see, what was an airport that we know had some data. So note that not every airport has data. So let's look at Damiel. And so we can see that there's one departure from plane 19, which is the one we just looked at, from Damiel to Corumba International. And you can kind of play around with this. So this user interface is mostly just to demonstrate the data, or to give you an entry point into the database. It's definitely not built to the best standards of user experience. But hopefully it's a great starting point for you to look into some of this. Let's look at, there we go. Corumba International has a lot of information. So there's some repairs, there's arrivals, there's departures. If we sort this by start date, then you can see we have some arrivals of planes. 53 went back and forth to and from Corumba International. So did 19. And now, so here's a little interesting widget that we built in here. One thing that you can do with cryptography that Fluree allows you to do quite easily, but can be implemented in other sorts of databases or blockchains as well, is you can have a scheme whereby you can validate or you can verify that a part comes from a particular manufacturer. So if you click here, you can download sample valid part signatures. So let's say that whenever you buy a part, this is loaded up kind of as a text file, this is CSV. Whenever you buy a part from a manufacturer, that part has a serial number, it has a manufacture date, and it also has a signature. And that signature has to be signed by that airline's or by that manufacturer's private key. And that manufacturer could publish out their private keys. So if we go here, not publish out their private keys, could publish out their public keys or the auth IDs associated with their private keys. So here we see we have two manufacturers in our database, Boeing and Airbus, and those manufacturers both have auth records. So let's kind of crawl the graph to see those auth records. And so this auth record right here, this is, let's just look at Airbus for now. This auth record right here is equivalent to Bitcoin account ID. It is tied to Airbus's private key and their public key. So the curve that we use for our cryptography is SECP 256K1. And for that particular curve, when you get a signature like this, and you have the original data that signature signs with a message, you can derive the public key from that information, and from the public key you can derive the account ID, and you can see whether or not a particular signature or a particular signature and message does in fact come from the person that it says it comes from. And for this widget, this is all just stubbed out. We might publish an update of this React application where it's not stubbed out. We're actually publishing our cryptography library, a more robust cryptography library pretty soon. So you'll be able to see that. But for now, it's just stubbed out. And so let's say we put in a serial number. And this is auto-completed. So you see these serial numbers are quite long. But one little nice thing that was made for this UI was a little autocomplete drop down. We're gonna select the manufacture date, and then we're gonna put in the part signature. And because these are sample valid part signatures, we expect this to come back as valid. So we press verify. It says valid, true, and the manufacturer is Boeing. But let's say we change let's say someone has valid parts or valid parts that come from a manufacturer with valid signatures, but they're trying to resell them at a higher rate because they want to say that the part was actually manufactured later than it was, so it's newer stuff. So if we just change one number in the manufacture date and we click verify, then it'll come back as false. And what's really cool about something like this is that you don't actually have to, this doesn't depend on Fluree at all. Boeing and Airbus and all of these part manufacturers could publish out their auth IDs to a number of different places. They could put it on Ethereum, they could put it on a Fluree database, they could just have it on Wikipedia. There's no loss of security when they publish out their auth IDs. And then anyone that has some cryptographic knowledge will be able to validate those part signatures, and it's not dependent on Fluree at all. But you can, store those parts in Fluree and then use our soon-to-be-published cryptography library to validate that information. We can look at another one if you'd like. So I'm just going to select the last one. And let me just copy this instead. You can play around with this. But like I said, this is all stubbed out for now for this little demo. But if we press verify, you can see valid, true, and the manufacturer is Boeing. And we can also see part by type. So we can select a different part type. And then we, through a collection of, I'll pull up the network tab. So I see one. I have to change it. You can see this query right here. So this is an analytical query that goes from the part number, and it selects the part type. It selects the plane ID that's connected to the part. It selects the serial number for that part. It selects any repairs for that part. And we use analytical queries are one really easy way to traverse a number of relationships at once. So you can't go, if you didn't have access to reverse references, you wouldn't be able to go from a part or from a part type to all of this other information. But because you can traverse the graph backwards and forwards and kind of several times over, so we're going from plane to plane sections to section parts, and then finally to part numbers, and that's kind of how those two different pieces of information converge. And so if you're interested in the queries for all these different screens, then you can just open up the network tab in Chrome, and there's like developer tools in Safari and other places, and you can check out the queries that we actually used, or you can look at the React application that we have packaged up with this demo. But yeah, let's say that there is a particular part like A14 that has a recall on it. And so what you want to do is you want to be able to quickly see all of the planes that have that part in their planes. You can see the serial numbers of those particular parts. And one other thing that we've pulled, which is really useful, is you can see the number of repairs. So let's say, we know that this part A14 is really sturdy, but there's an issue with the method that what we thought was best practice for repairing this part. So if this part has been repaired more than 3 times, then we have to replace it for safety reasons. So anyways, we can really quickly see, how many times this part has been repaired, and as well as the plane ID that it belongs to and the serial number. Another thing that you can do is, these are just a number of screens that we created, but you can imagine being able to, take that serial number or take those repairs and look at the actual details of the repairs, looked at the people that repaired it. This is one of the really strong benefits of having a graph style database, is that you can pull all of this information really easily. And we can also look at part by serial number. So let's look at this serial number right here. So it's B1CA. And hopefully that only returns one result. B1CA, great, it only returns one result. And we can see the repairs for that part. I see. And so there's, like we saw on the last page, there were 5 repairs. So we in fact see 5 repairs. And there are a number of trips. So there's 35 pages. So most of these, most of the things that this part took part in were trips. But this part also has been repaired 5 times. So we can see these repairs here. We can see when these repairs happened. We can see the location that they happened in, and the description of that part. And again, we could also pull up other information like who was the lead person for that repair and things of that nature. Yeah, so anyways, happy searching through this little demo. There's quite a lot of information here. So there's almost 17,000 different trips. There's 5,600 different repairs and 101 planes. There's a lot of information to dive into. And one thing that you can do if you're, especially if you're interested in developing with Fluree or getting a feel for some more complicated queries, is you can look at a sample query for Fluree. And these are all analytical queries. And you can kind of expand those queries to get the information that you want and play around with it and use things like filters and things like that to get a better feel for how to write really complicated analytical queries. All right, and the last thing that I want to talk about before we end this is a little bit more focused on developers, but I think this might be interesting for anyone that's looking at Fluree for any reason. This, like I mentioned, is all simulated data. So this isn't actually real data. The airports, those are all real airports that we got from a list. But the actual like trips themselves and the repairs and everything like that is all just simulated data. And so I just generated a bunch of random transactions using Clojure. But what I did was I actually built up smart functions in FlureeDB that help make that really easy. And you can see there's for 17,000 trips and such like a rich wealth of data, there's only a handful of smart functions that I had to create in order to make this happen. So for when I generated the planes, I used Clojure to randomly generate serial numbers and things like that for a plane. But I also used a smart function, so I used random airport seeded to pick a random airport for the first trip of every single plane. And you can see this is just a query that selects all the airports and randomly picks a random offset and selects just a single plane. And that's how we got a random airport. And so each of the planes starts at a random airport. And then when we wanted to give that plane more trips, we had to find out where that plane was currently located. So if we have a plane that's currently located in Japan, we don't want it taking off for the purposes of the demo. We didn't want this taking off in, let's say, Colombia. That doesn't make any sense. So we had to figure out where the location was of that plane. And the only thing that we had to do was we had to write a smart function. So we basically had to stringify a query that finds out the last trip of that plane and find the end location of that trip. And so we use this smart function to randomly generate trips for planes that we didn't necessarily know where they were located. I mean, we could query that ourselves, but when you're randomly generating so much data, this is quite a lot of data. It's really, really helpful to have these functions. Also for repairs, we have this smart function rand part, that just found a random part, and that was what part was done for the repair. In addition, when we wanted to do a repair on a plane whose location we found out using this plain location smart function, we wanted to find a person for that who was in that location who we could list as the lead person for a pair. And we didn't look a lot at different people, but basically people have different roles, and one of the roles is head mechanic. And so we wanted to be able to, with this smart function, just pick a head mechanic, or the head mechanic. It's just a single head mechanic. Pick the head mechanic at a location. For this smart function, this picks in a particular location, it picks a random number, or it picks a number that you provide, but it picks, let's say you provide the number 3, so it picks 3 random mechanics at that location. These are helper functions so num airports helps us write random airport seated. And then last flight date is also useful. So when we're generating trips for planes, we wanted to make sure that there was continuity in the timeline of those planes. So we also have a smart function called last flight date, which again all these smart functions are really, really simple because this is just a stringified query. So if you figure out what query gets you the information that you want, and maybe that query can have a single variable that changes so that you can get the last flight date of any plane by ID, then you can stringify that query and stick it in a smart function, and then you can use it whenever you want without having to think about it. And so that's just a really quick walkthrough of this demo of some of the things that you can see with it. And there's really a lot more that we can talk about with this example. And you're welcome to reach out to us on Slack via email at support@fluree, or down below in the YouTube comments, wherever you'd like, to ask more questions or to make comments about this video. So thank you all. If you've listened to this for all 30 minutes, I hope that you gained a lot from it, and you now have more tools to understand the different projects that Fluree can help you with, as well as how you can play around with this particular database.